Hi, so in this video, I'm going to give you sort of a little tour down factor lane, if you will. So these are your practice activities. You'll see that they're sorted by their classifications. This is a must do. So you're going to start by finding the factors of these numbers. There's an example here done for you. So when you think about finding the factors, this is a factor T. So we're going to always start with 1 and the number itself. So 1 times 44, when we multiply them, we'll hit our target number of 44. We go sequentially. 1, 2 is the next number. Well, 2 works because 44 is even. So 22 times 44 hits our target number of 44. 3, add the digits and you'll see if the number is divisible by 3. 4 plus 4 is 8. 8 is not divisible by 3, so neither is 44. What about the number 4? Well, yeah, I do 40 divided by 10 essentially, or sorry, 40 divided by 4 is 10, and 4 divided by 4 is 1, so we have 11. What about 5? 5, 10, 15, nope, it doesn't end in 5 or 0. I know 5 is not our hero. 6, well, if you get both 2 and 3, then you get 6 for free. It's not divisible by 3, even though 44 is divisible by 2, so 44 is not divisible by 6. 7, if I count by 7s, I won't hit it. 8, won't hit it. 9, also won't hit it. 10 doesn't end in a 0. 11, well, we already have 11, right? 11 is already a factor. We don't need to put it in our list again. We only need it to be a factor one time. So now we're going to go ahead and count them up. 3, 6, so 44 has a total of 6 factors. This is the same strategy essentially as a factor T, just in a slightly different look. So we're finding the factors of 48. Well, on our bow, right, we have 1 times itself to get 48. Is it even? Yes. So 2 times 24 is going to get us our next factor. You'll keep going, right? Test 3, 8, 9, 10, 11, 12. Well, 8 plus 4 is 12, and 12 is divisible by 3, so is 48. And then you'll find the pair that matches. So here you're going to solve a little bit of a mystery. So we're going to find the factors. A factor T, as our pro tip here, can be a helpful strategy. So the factors of 63 are listed in order: 1, 3, 7, 21, 63, but there's one that's missing. So we're going to try to solve this mystery of which one's missing. So when I do a factor T, that makes sense to my brain. 1 times itself is always going to be first, and that happens here as well. 1 times 63. We can turn it into a rainbow if we wanted. 3 times 21, right? And then we have 7 times, ooh, well, 7 doesn't have a pair, so we need to find its pair. So we had our 3, our 1, and then we have 7. Well, 7 times what gets you 63? We know it's 9, so the missing factor becomes 9. So here we're kind of solving another type of mystery. We want to know not what the factors of a number is. In this case, we're going to look at 9 first, but how many factors there are. So I might just quickly on my paper kind of sketch a T. 9 is our target number. So I have 1 times itself is always going to be true. And then I go sequentially through. 2, 2, 4, 6, 8, 10. Nope, don't hit it. It's also not even. 3, well, yeah, 3, 6, 9. 3 times itself. 3 times 3. We have the same number repeated on both sides, so we know we found all the factors. So we have discovered that 9 has 1, 2, 3 factors, right? Even though 3 has a pair, it's the same number. It's the same factor. So it has 3 factors. So we're going to go ahead and swoop up this 3. Okay. You're going to keep doing that. Here's my factor T for 45. You can see I have 1 times itself, and then we've gone through and we can see it has 6 total factors. Here you're using what you know about divisibility rules to help you find if or discover if certain numbers have 2 in this case as a factor. So what we know about 2s is if it ends in an even number, right? If your target number, in this case, let's say 42, ends in an even number, we know 2 will be a factor, right? You'll be able to do 2 times something to hit 42. So your job here, you can see I've done some examples. Your job here is to find the other ones in this row that have 2 as a factor. Here you're going to determine if each of these is true or not true. Is 7 a factor 91? In other words, if I count by 7s, will I hit 91? And you can see that if I count up by 7s, I do indeed hit 91. So I'm going to and drag a Y up for yes. Here's an example of a Venn diagram being used to find common factors of 2 numbers and seeing which they share as factors. So in this case, we have